All right, good morning. And today we are going to continue on with chapter 6, continue on working with the unit circle. So if you open up your packet, I recommend you go to page 6.3 here. And on 6.3, first thing we're going to talk about is what's the difference between the inside and outside number on this unit circle. So if we look here, we've got our unit circle here, and we want to know what's the difference between those numbers that are in here and those numbers that are in parentheses on the outside. So if we think about it, the inside numbers, those represent the angle, okay? So when I say the angles, that's specifically like our theta, okay? So like in here, the central angle, and that can be written in one of two ways. Remember, just like we said, inches and centimeters both mean a measurement for length. When we're dealing with our angles, it can either be in degrees or radians. And 30 degrees and pi over 6 radians, that's equivalent. It's just in a different unit of measure. Okay, so we either have degrees or we'll have radians, depending on which one we are referencing. Okay. Now, meanwhile, the outside numbers here refer more like it's a coordinate plane, and those are the values of both our x and our y. So square root of 3 over 2 is how far to the right it is, half is how far up it is, and these are going to be our values, and once again, there are x, y values. So we've already talked about the sum, but how do we find these values of sine and cosine? Okay, so as we said last week, we know that sine is the same thing on our unit circle as just y. Cosine is the same thing on our unit circle as just x. Now keep in mind, if you're not on a unit circle, it's not always the case. But with a unit circle, sine is simply our y, cosine is our x. So find the unit circle, or use the unit circle to find the exact value of sine and cosine. So it's up to you how you do this, but in my opinion, memorizing would be helpful. Okay, and if you want to do that, that's a good idea. But right now, I don't think most of you are there yet. So sine of 60 degrees. We're going to look for the y value at 60 degrees. So if we look over here, 60 degrees right here, the y value, square root of 3 over 2. Okay, our next one, the cosine of 135. So that's our x at 135. So 135 is over here, it's in the middle. The x value, negative square root of 2 over 2. So I recommend maybe pause the video, try to figure out these next four. And I'm sure that some of you didn't pause it, but if you want to take the best advantage to see, are you ready? I recommend you do that. So this next one, cosine of 270. So we go in here, 270 is all the way at the bottom. Cosines are x. That is going to have a value of 0. Now the next one, sine of 210. So our y at 210. 210 right here, the y value, negative half. So everything we've done so far on the front here, this is all kind of a review of what we did last week, right? We got two more here. Cosine of 7 pi over 4. This time they gave it to us in radians, 7 pi over 4. So we look here, 7 pi over 4. 7 pi over 4, and it's cosine, so square root of 2 over 2, because it's our x. And then our final one on the front page here says, what is the sine of pi? So sine, remember, is our y value, and at pi, that y value is 0. All right, so now we continue on, and when we're finding tangent, remember, tangent, we said on the unit circle, can be thought of as y over x, or if you prefer, you can write that as y divided by x. Now, if we look here at this first one, it says the tangent of 30 degrees. So 30 degrees, we come here, right here, y is 1/2, and x is square root of 3 over 2. So right here, tangent of 30 degrees, it's the same as 1/2 divided by square root of 3 over 2. Now some of you might be wondering, how do we divide when we have two fractions? Okay, so over here I recommend you write yourself a note. I'll do this in red. So to divide fractions, you could, divide. It's the same conceptually as what we always do with dividing, but an easier way maybe to think about it in your head is, in order to divide fractions, if we flip the second fraction and multiply. So dividing is the same as multiplying by the reciprocal. So flip the second fraction and multiply. And it might help you. Some of you have probably heard this before with adding and subtracting when we dealt with polynomials. So maybe you can mention to yourself, keep, change, flip. It's the same conceptually. Keep, change, flip. If you use that same idea, it will work. So what we mean by that is we're going to keep 1/2. We keep that as is. We change the divide to a multiply. And we flip, meaning we find that reciprocal. So we flip the second one, so 2 over square root of 3. Now from here, we have a 2 on top and bottom. Those can cancel. So I can rewrite this as 1 over the square root of 3. That's our answer, except it's not in proper form. So we're going to multiply that by square root of 3 over square root of 3. And we will find the tangent of 30 to be square root of 3 over 3. All right, our next one, tangent of pi over 4. So we go to pi over 4, that's right here next to it. Pi over 4, so we got square root of 2 over 2, square root of 2 over 2. Now the good thing about this one will be easier because if we think about it, square root of 2 over 2 divided by square root of 2 over 2. Now if we keep, change, flip, keep, change, and then flip. At this point we have square root of 2 and square root of 2 will cancel, 2 and 2 will cancel, and we will be left with 1 over 1 or 1 as our answer. Now, our next one, tangent of 60. So as we keep going, tangent of 60 here, 1/2 and square root of 3 over 2. So we got to have this one on top, or first. So square root of 3 over 2 divided by 1/2. Now we're going to keep, change, flip. So square root of 3 over 2 times 2 over 1. Once again, our 2's cancel. And we're left with square root of 3 over 1. Or you could just put square root of 3. So if you prefer, square root of 3 is fine also. Okay, tangent of 0. At 0 degrees, 0 degrees is over here. We have 1 and 0. So if we write that, 0 divided by 1, which hopefully you know is just 0. Now our final one up here, tangent of pi over 2. So pi over 2 is up at the top. Now this one's a little different. The 1 and the 0 are still there, but the 0 is on the bottom. So if we have 1 divided by 0, hopefully you remember, we can't divide by 0. That doesn't make sense. If I have 1 pizza and I divide it between 0 people, what? I don't get that. And I don't think you can understand that either. It just conceptually does not make sense. Okay, so what we write here is undefined. Okay, that answer would be undefined. Now, we could find the tangent for all of those, and if you want to, you still can, just using this method, y divided by x, keep, change, flip. But we're going to go ahead and write on all of these different values. So let's see, I'll use orange. And we found some of them we did not find. So if I were you, I would flip back to your unit circle and write them on the edge. Now here's the thing you got to remember. We're starting to get a lot of information on here. So this is our tangent. So there's 0. And we also know that this one is 0. Up here, we get square root of 3 over 3. Here at 45 degrees, we get 1. At 60 degrees, we get square root of 3. Okay, now as we move over here, it's going to be the same. Like it flips over, but if you think about it, this time we had a positive divided by a negative, so it would become negative. So that one's negative square root of 3. Over here at 135 degrees, negative 1. And at 150 degrees, negative square root of 3 over 3. Now something, I forgot at the top, we already said 90 degrees. We know that one is undefined. Now something that's kind of neat about how this works, if you drag across 180 degrees, here was 0, here was 0. It always matches up for the tangent. So right here, square root of 3 over 3 at 30, 180 degrees across the 210. It's also going to be the square root of 3 over 3. And that will always be the case. Now, some of you might be thinking, but that doesn't make sense because these are negative. But they're both negative. And a negative divided by a negative becomes positive. Okay, so with that logic, then we know 225 degrees is 1. 240 degrees just comes to square root of 3. At the bottom here, this is still going to be undefined. And then over here, 300 degrees becomes negative square root of 3. This one will become negative 1. And our final spot we got to fill in at 330, negative square root of 3 over 3. Okay, now, that's a lot of information. Okay, so try to keep it organized. I know this is kind of chaotic. Maybe it's more difficult. If you need to, let me know, and I'll get you another copy of this. You can fill it out a little neater if yours is messy. But if we go here now, the final thing says now use the unit circle to find the exact value of cosecant, secant, and cotangent. Okay, so the first thing I want us to do is think about cosecant, secant, and cotangent and what they are. Okay, so we know cosecant, that one matches up with sine. Okay, sine goes with cosecant. Sine is y. So cosecant, all we got to do is flip the y. Okay, or maybe you can think of it as 1 over y. Now, we also have secant. Secant matches with cosine, which is our x. So we'll flip the x. Or you can think of that as 1 over x. And then our final one, cotangent, this results in us flipping tangent. It's the reciprocal of tangent. Okay, and if we think about that, it was normally y over x. And in our case now, it's going to be x over y. Now, if we look here, cosecant of 60. So, cosecant is flipping the y, so 60 degrees. So we can go back over here to 60 degrees. The y value there was square root of 3 over 2. So rather than it being square root of 3 over 2, we take the reciprocal of that. It becomes 2 over the square root of 3. Now that'd be our answer, except there's a square root on the bottom. Can't leave that, so multiply it here. We'll get 2 square root of 3 over 3. And that is our cosecant. Now, we could write all the cosecants on here, all the secants on there, all the cotangents, but this is already very full. I think if we add anything else, it's going to get kind of messy. So instead, we're just going to each time just find the cosecant, secant, and cotangent. You'll just solve those. So now, secant of pi. Remember, secant, we got to take the x, and we'll take the reciprocal. So secant of pi, we'll go to pi. Over here, the x was negative 1. Okay, now if the x is negative 1 and we flip that, if we think about it, so the x equals negative 1, which is the same as negative 1 over 1. If we take the reciprocals of that, switch those, we're still going to get the same answer, 1 over negative 1, which is just negative 1. Okay, 2 more. Example 14 here, cotangent of 7 pi over 6. So remember, cotangent, we can flip the tan or take x over y. since we already know the tan, we wrote those down. So if we take the tangent, we can just take the reciprocal. So 7y over 6, 7 pi over 6. We go here, the tangent square root of 3 over 3. So I'm going to take the reciprocal of that, or flip it, which would be 3 over the square root of 3. Once again, we got to multiply by the square root of 3 over square root of 3. We get 3 square root of 3 over 3. However, here we can reduce. These 3's can cancel, and we are left with square root of 3 as our answer. Now, you might be wondering, why didn't we reduce that square root of 3? It's in the square root, so that is not going to be divisible by 3, okay? So we just have to leave it. And our final one, cosecant of 5 pi over 4. So we come over here. We know cosecant is the same as flipping the y. So 5 pi over 4. So we look on here, 5 pi over 4 down here. The y, negative square root of 2 over 2. So if we flip that, it will become, let me switch back to blue. It will become negative 2 over square root of 2. So we flipped them. Got to multiply that one. We're going to get negative 2 square root of 2 over 2. Once again, these can cancel. And our final answer, is just negative square root of 2. All right, so that's all for today. Make sure that you guys take a look at the It's Learning assignment that we have for today. Give that a go. And if you have any questions, please reach out. And I'll see you guys soon.